Hello, my name is Daniil. I'm a member of the Department of Intelligent Information Technologies of the Belarusian State University of Informatics and Radio Electronics. Together with my colleagues, we are developing open semantic technology for intelligent systems. So today we are going to discuss some main points of that technology and consider several examples. So let's begin. The first main point is that our technology is not a single system or a program, it is a real technology. That means a whole complex of models, methods and means for intelligent systems development. All of the modern technologies are too complex for usual developers. So we are going to give an opportunity to create intelligent systems even to those who are not specialists in the sphere of artificial intelligence. Our technology provides universal knowledge representation language and a universal knowledge processing model, both based on unified semantic networks. Also we have universal external representation languages, for example hypertext, graph and so on. Few minutes later we will discuss internal representation and external representation too. Our technology provides platform independence. That means that there is an ability to run the same system on several platform implementations, including even special semantic computer. Our technology provides libraries of reusable and interoperable components for intelligent systems. That means that development will begin faster and cheaper. All of that provides us an ability to create universal problem solvers, universal knowledge processing machines, and so on, which are independent from the subject domain. Now let's discuss the representation used in our technology. As you know, semantic web represents knowledge as triples. Each triple consists of subject element, object element, and predicate or relation between them. In OSTIS technology, we use semantic networks for representation too, but our networks has set theoretical interpretation. What does it mean? Each element of our network is a sign of the set. For example, this triples says that element X is an element of the set Y. In mathematical language, we can write that fact that way. And the next example, the set A consists of elements A, B and C. In mathematical language, it will look like that. Some example from real life. Here we can see that John is a student and John is a man too. There is some analogy with object-oriented programming. We can say that object John is an instance of class student and of class man. In our technology we call such kind of arc main type arc. Its semantic is accessory. That means the relation between set and its element. The next type of arc is common type arc. Its semantic is not defined basically and should be defined by additional facts. For example, element A is connected with element B by the common type arc, which belongs to the rel relation. That means that element A and element B are connected with the rel relation, and element C with element D are connected with that relation too. In mathematical language, we can write that fact that way. Let's consider relation older. For example, John is older than Peter and Anne is older than John. So we can say that John and Peter are connected with the relation older. And now more complex example in what we can see that there is a man Michael who has wife Anne who's a woman. They both live in Sydney. Sydney is a city, and they have son John. So Anne is John's mother and Michael is John's father. Just right now John lives in Minsk and Minsk is a city, as a Sydney too. Such an approach gives us an opportunity to perform search even without special interface components. We call that approach pattern search. Let's consider our old example. Let's imagine that we want to know who lives in Sydney. So we create special pattern for that. We fix Sydney and fix relation live in. All other elements are variables, and these two elements are constants. Search algorithm is quite simple. We just need to realize which subgraph of that graph is isomorphic to the given pattern. For our example, isomorphic subgraphs will be the first one and the second one. First one about Michael and the second one about Anne. So we perform search, and the answer, as you know, will be Michael and Anne both live in Sydney. Let's change pattern a bit. For example, we want to know who lives in Sydney and who is a man at one time. We perform search, and the answer will be only Michael, because Anne is a woman.